Now, let's talk about compound inequalities. So, a compound inequality is just an inequality with more than one statement. So, here we have this long expression that really just means that 1 is less than 2x plus 5 and 2x plus 5 is less than 22. So we're going to have to find our critical values for both of those expressions, realizing that they combine together to make the expression that we're working with. And so I solve the left equation and I find a critical value of -2. And when I go through and solve my right equation, okay, I am going to find a critical value of 8.5. Okay, and I'll go ahead and mention the fact here: x equals 8.5. That's totally fine. Most numbers in real life actually don't work out to be nice whole numbers. We just use those in algebra to make the calculations a little bit easier for you. Okay. I am in this case going to skip the check step. I did it on my own, just in the interest of space and the fact that you've probably seen it before. Okay, so I'm going to plot my two critical values. Okay, and my test intervals are going to be when x is less than -2, when x is in between -2 and 8.5, so -2 is less than x, which is less than 8.5, and when x is greater than 8.5. And for all of these, I just need to pick a test value that is within those ranges. So x is less than -2, I can use x is equal to -5. For the in-between, I can use 0, so x equals 0. And for the value or the interval x is greater than 8.5, x equals 10 works just fine. Okay, and then I just go through and I take that entire original compound inequality, 1 is less than 2x plus 5, which is less than 22, and I plug in my test value. So -5 for the first one, okay, does not work. And when I plug in 0 for the second one, I'm going to see that it in fact does work. So I know that that interval is good. And the last one, I am going to see that it does not work. And from experience and knowing some patterns, you'll actually be able to know that this should look this way. And after we do the other type of compound inequality, you can kind of see that. But there's no difference to the procedure here. We're just having to do a little bit more work because there's two inequalities. Now, this is the other one. We've got an or statement. So you'll see that it already separates out our two inequalities. And so we're, again, going to have to find two different critical values. Okay, and through a little bit of algebra, we're going to find that one of them is x equals 3, right? And then through a little bit of algebra with the other one, okay, add 1 to both sides, right? And use our additive identity, divide by 2, and we're going to find that the other critical value is that x equals -3. Now, with this one, we have to be a little bit careful when we're dealing with our critical values, okay? Because the first critical value, 3, okay, came from a greater than sign, not a greater than or equal to sign, okay? The second one came from a less than or equal to sign, okay? So the first one came from a greater than sign, right? So I'm going to get an open circle at that 3. And then the -3 came from a less than or equal to sign. So I'm going to get a closed circle at that critical value, -3. Then I'm going to look and see what my test intervals should be. So x is less than or equal to -3, okay, over the left there. Or it could be in between the two values. Again, you'll notice that I have that closed circle next to the -3, okay, since that came from a less than or equal to sign. And then the last one was x is greater than 3. So I pick my test values. X is equal to -5, x equals 0, and x equals 5. okay? Just picking values that are in each one of those intervals. And I go through, and now for this one, since it's an OR statement, it only needs to work for one of them. So pick carefully, okay? Pick the one that you think would work. And for one of them, or if it doesn't work, then you have to test the other one anyway. So for this first one, I did a little mental arithmetic, and I feel confident that the second equation, 2x minus 1, inequality, will work. And lo and behold, I get negative 11 is less than or equal to negative 7. Worked just fine. And since it's an OR, only one of them has to work. So I know that x is less than or equal to negative 3 is good. And then I'm going to do that second one. And again, a little mental math before I choose my inequality. I think that first inequality is going to work. So I plug 5 into the first inequality, do all the arithmetic there, and I get 11 is greater than 5. That works. So I know my first and last intervals, those outside intervals, work. Now, again, because I've been doing this for a while and I know some of the patterns, I actually know that this middle one is not going to work, okay? So what I'm going to do is I'm going to plug it into both equations. I didn't do any mental math here. I feel confident it's not going to work. And what we end up with is two inequalities. Negative 4 is greater than 5, and negative 1 is less than or equal to negative 7. Neither of them work, so I know that middle interval is not a valid solution set. Okay. Now, look at your notes and look at the two patterns, and you're going to notice that there's something about the AND inequalities versus the OR inequalities that can help you to guess which intervals are going to end up being your solution sets.